Hello all, welcome to the video lecture series for the subject compiler design. Now I am going to teach you people about how this bottom-up parsing technique is really working with the number of algorithms which is actually processing with bottom-up parsing, right? So what generally the bottom-up parsing do is, it is going to construct a parse tree and the projection is to reduce the input string and it is using only the rightmost derivation part to do it, right? So this is the basic principle, and we can see how this bottom up parsing starts with an input symbol and it is going to construct only the parsing tree, or else whether it is going to reduce the string to get the starting symbol alone, right? Let me show you some example so that you can able to understand. So as you all know, this is the production. This is the basic production. E tends to E plus E, for example, right? So in this E tends to E plus E, you can able to see that this is the rightmost non-terminal and this is the leftmost non-terminal. In between, you can see there is an operator called plus. So what is this rightmost derivation start? Exactly here. So from here, you are going to start and you need to read a root, right? So from rightmost direction to the leftmost direction, this is how we are going to do. We are going to see how this particular root node we are going to find. So this computer mechanism, it is going to scan from left to right. If any given input is attempted, it is going to scan from left to right or right to left. We are going to see that rightmost derivation technique by using the bottom up parsing, right? The first algorithm we are going to see here is shift reduce parsing, right? Let me tell you what is this shift reduce parsing. It is a technique which is used in bottom up parsing to attempt, and it is going to construct a parse tree with any given input string, right? Again, it does the same, that it is going to start with the leaves and it is always working to reach towards the root, right? Now we can see this is the action performed in this shift reducing parsing algorithm, right? The first part here you are going to see, we are going to shift all the terminal terms, that is action performed, to the left mode direction or right mode direction. We are using right here, and we are going to reduce it with the given input symbol. We are going to match it, and it is going to come with the acceptance state when the starting and ending parsing is going to be passed, right? If this input is not matching, then we are going to say it is a error part, right? This is how it exactly going to work. Now I am going to perform this all these four different terms in shift reduce parsing with one given example, right? Now you can see here, this is the example. The production rule has been given. The production rule is E tends to E plus T, E tends to E asterisk E, E tends to open bracket, this is a terminal term, and E is a non-terminal term, and again close bracket is a terminal term. So E tends to open bracket, E close bracket. So E tends to ID, ID is a terminal term. As we all know, capital E here, it is a non-terminal. This is in left and this is in right. So now we are going to perform all the action with given input. So here you can see the given input is ID1 plus ID2 plus ID3, right? What is the first step we are going to do here? It is, we are going to take the rightmost derivation for this particular given production rule. You can take any production here, right? Any, this is a given grammar. You can take any production here. Either you can take E tends to E plus E, or E tends to E asterisk E, or you can take anything here, and you are going to perform the rightmost derivation here, right? So let me show you the first step. Now I have taken E tends to E plus E, as I already told you. So we are going to take this particular rightmost part here, it is E. You can see here. I am going to take this E. I need to match with this particular input string. I need to get the final output as ID1 plus ID2 plus ID3. This 1, 2, 3 or the resemblance of number of times this ID has been repeated here. Okay, 1, 2 and 3. These are all the inputs. We used to call it as a terminal term, right? So now I will show you how exactly this E has been replaced. Now I need to get this particular thing. Either you can go to E can be replaced into E tends to E plus E, or else it can replaced into E tends to E asterisk E, right? So I'm going to replace that. I think this part here, it is asterisk, right? It is not plus, it is asterisk, right? So now we are going to see that how exactly this input is matching. Now I am going to replace this particular right mode direction E into E asterisk E. The second step you can go to that. Again this E, this particular E. First time I have replaced it. Second time I am going to replace that particular thing here. That is the rightmost. I am going to do only the last term which is available in that particular expression. This is E. So this E has been replaced into, this is the final one. So we need to have only three different terminal terms. So this is the last non-terminal. I am replacing this E, right? This re has been replaced into ID. So here you have E can be replaced into ID. Everything has been given in this particular production itself. You can able to just place and we are going to shift. Okay. So I am going to replace this. This E has been replaced into ID. Here it is, right? So I am going to mention the number here. This is the number. So right number, we are going to mention it as ID number 3, right? So we have the next replacement here. This is the part. So this is the center non-terminal term. I am going to replace that into E tends to E asterisk E. You can see here, I have replaced it. So I am given a number, it as 2, right? So I am moving on to the last part of it. That is the only non-terminal available in this particular expression, that is capital E. So I am replacing that also with the same ID and I am giving that as a number as 1. So now you can able to see this particular ID1 plus ID2 asterisk ID3 has been matching with this particular input string or not. This is the first step, right? So I have taken the right mode derivation and I have resolved it, right? Now I need you people to understand this is the first step. Second step is a direct thing. That is, second step is just we are going to shifting it, reducing it and parsing the technique, right? Now in this particular part, I need to explain you what is a stack, what is an input and what is the action, right? So here you can see stack is always whatever the element, whatever the terminal or non-terminal element you have in this input string has to be moved. And the stack will be always checking with the input whether it can be replaced. You can just shift and you can replace. Everything will be happening only in this stack, not anywhere else, right? This input string, you know very well, it has been given in this production itself. So this is the input string ID1 plus ID2 plus ID3. I have taken the same input string here. You can able to see that, right? I will just check with this particular thing. This is the first part, right? Now ID1 plus ID2 plus asterisk ID3 and dollar. This dollar symbol has to be initiated. That is, it is the starting state and it is also the ending state. So the mechanism has to understand where it starts, where it ends. So we need to add this initially, right? The first step is we are going to shift something from this input to the stack, right? Now the first step is ID1 has been taken into stack, right? This method we used to call it as shift. We need to mention an action, it is shift. Now whether we need to check whether this terminal which is available here, whether it is a non-terminal or terminal which is available in stack can be replaced or not. Yes, it is. We can able to replace that. Yes. Now here this ID can be replaced into E. You can check here. This ID can be replaced into E. So I am going to replace this particular ID here. You can check it here, right? This ID has been replace. That technique we used to call it as reduce, right? So this ID has been replaced into E. Once this part is over, again I am going into this particular input part, and then before reducing we should not shift anything. Just check if there is no possibility of reducing, then you can directly go and shift. If there is a possibility of reducing, once you have shifted, you cannot reduce anything at the beginning. So we need to see all the possibilities of reducing this first, and then we need to go to the input and then shift. This is the procedure, right? So we have a plus here. Plus is a symbol. We need to move that. That is a terminal symbol. So I am using this shift method here, right? The plus has been shifted to stack here, and then plus cannot be replaced by anything, right? So there is no replacement for plus. So if there is no replacement, and the next step I am going with ID2, right? So now you can see that the ID2 has been taken here. So ID2 has been taken into this particular stack. Now you can see there is a possibility of reducing it. Yes, it is. This ID2 or ID3 or ID1 anything is called as id. This id can be replaced for the shifting, right? So now we have replaced this id. So this id has been replaced into e plus e, sorry, only e. Finally we have e plus e, right? So let me take you to the next part. So here we have this asterisk here. There is nothing to reduce here. If you want to reduce here this e plus e into some other thing you have in production rule, then you can do it. So if it is not necessary, we'll move on, no issues on it, right? So next thing is I am shifting this star, that is asterisk, to the next part because there is no replacement for me. So I am just shifting it. So shifting operation, that is an action, has been performed, right? After shifting, we need to check whether this asterisk can be replaced. Definitely not. This asterisk cannot be replaced into anything. So again, I'm looking for this particular ID3. So now this ID3 has been shifted, right? So we have e plus e asterisk id. Now this id is again reduced into e. As you all know that this is what we are doing from the beginning. We are shifting it and reducing it. If there is no possibility of reducing, we are shifting it from the input, right? So after shifting this id3, again we are doing this same operation. This id can be reduced into e, right? This is what happened over here, right? Now you can see here all this inputs has been passed, all the input has been reduced, all this input has been taken into the stack, right? Now we need to check for the maximum number of reduction in this particular stack. Now this e asterisk e can be replaced into e. Sir, how? Let me tell you how this e asterisk e can be replaced. You can check over here. This e asterisk e can be replaced into e, right? So this is how it has been reduced. So now we are seeing for the maximum possibility. So I am taking to that particular part again. You can see here this e asterisk e has been replaced into e. So that is what we used to call it as reduce, right? So it has been reduced. Now again this e asterisk e has been replaced into e. So we have this e already here. You can see that this e has been taken to the next level. Now we have e plus e. We are going to check whether this e plus e can be replaced into any other non-terminal symbol. Yes, it is possible. We can reduce this e plus e into e, right? We need to see for the maximum symbol, right? So now as you all know that this is the last state we have, right? Let me check whether this e is a starting state or not, right? So let me take you there, whether we are going to check the last statement here, whether this e is a starting state or not. You can check it. This is the starting state, right? And this is the ending state. Now we got this particular thing, that is e we got in the stack. Here it is, e we got in the stack, and we got a dollar in the input string. So this is a starting state and this is the ending state. Now when this comparison has been made, we are going to compare whether we are getting this starting and ending state as dollar, then your input symbol is accepted in this particular grammar, right? So if there is no matching has been found, you are not getting this particular stack as a starting state, then your algorithm is totally wrong and this input symbol cannot be accepted for any given system parsing technique. Thank you.